Hello, in this video I'm going to talk a little bit about angles. So we start off with some basic terminology. So one thing that we can look at, for instance, is if we were to, say for example, draw a set of 2 points. So let's say that we have points A, and then let's say that we have points B. Now, interestingly enough, I can draw a line right through these sets of 2 points. And we'll just indicate some arrows like this. Okay, well, in any case, we know that we can always, give this a name like uh, line AB, for instance, and we'll just put something like this. But we can also, for example, say that if we were to do the same thing similarly, like where we have a set of 2 points like A and B. So we have A and then we have B. Well, in this case, we have that this is just really the segment. Okay, so we have that this is just a segment. Okay, well, furthermore, what if we were to pick A as an endpoint, or let's say starting point actually, and we'll choose B as an endpoint. And we'll draw a line from A to B, but we'll put like a little arrow like this. Now, in this case, actually, let's just change this a little bit. Yeah, so actually, we'll just change it like this. We'll just put like an arrow like that, and then we'll just put B right here. Okay, so this will be B. Well, we have that, yeah, this was the segment AB, and then we have that this was the ray AB. Now, what we're going to look at, for example, is just we're going to look at two sets of rays. Okay, so let's say that we have our ray and it points in this direction. And then let's say that we have another ray like that. And we actually might end up just dropping this terminology, for example. Now, let's say, for example, that we were to rotate from here to here. Well, in that case, this would indicate what I would call a positive angle measure. Now, in that case, we could actually, furthermore, label the angle that we have. So in this case, maybe we can call it theta. So in this case, theta is positive. So we have that, yeah, that theta was positive. Okay, well, what if, for example, we were to kind of do the same exact thing where we look at a ray and we have another ray like here. But in this example, we go ahead and we create an angle measure like so, and then we call this theta. But here you have that theta is actually a negative angle. So it's kind of interesting because like if you go in a clockwise motion, then in that case you have that it's negative. So in that case, yeah, we know that it's less than 0. But if we go in a counterclockwise, then we have that it's going to be positive. Now, one thing that we can mention, for example, is what if we had that, we want to know exactly like what do we call this ray right here and what do we call this ray right there. Now, sometimes, we can probably explain it before looking at positive and negative angles, but more or less it's all the same. So, for example, if I had a ray that started like this, and then I had another ray that went like that, well, in this case, we have that there is a name for this ray right here. It's called the initial side. But then over here, you have that this over here would be called your terminal side. So like if you've ever heard the term terminal side, then basically it's just talking about the end right here. Now, furthermore, what we need to do is indicate an angle measure. So because the terminal side is right there, we're just going to go ahead and indicate that we went in a counterclockwise motion, and we're going to name this theta. So we have that theta is in the direction of the terminal side. Now, normally we actually do tend to name like where the two rays will meet. So like for example, you can call this vertex A. But normally you may not even think about it that way, which I mean it's all the same. So in our discussion of angles, we actually have to talk about, for example, like rotations or revolutions for that matter. So that way you can kind of get a feel of, um, what does it mean when we talk about a complete revolution. But that leads me into this whole discussion of basically degree measures. So when we look at degree measure, basically one thing that we'll do is we'll just consider a ray, and what we'll do is we'll just rotate this counterclockwise like so. But one thing that you would have to basically take note of is that essentially we had that you had one single rotation or revolution is basically equal to 360 degrees. So what this means is that if you want to look at it another way, you have that 1 degree is actually equal to 1 over 360 of a revolution. Okay, and that's kind of interesting because you can kind of relate it to, for instance, like the turning of a wheel, and things like that. Because if you look at, for example, your car, you'll notice that your car normally does say, like, for example, miles per hour, but if you'll notice in the odometer or speedometer, you have that it's going to say the RPM, which is basically the revolutions per minute. So it's basically kind of telling you like how fast is your wheels turning, basically. So you can kind of look at it that way. Now, you do have that when it relates to angle measures. So looking at some angle measures, now we mentioned the angle measure theta. So what I want to look at is the different types of angle measures, for instance. Now, whenever you have that there's an angle measure that's like so, let's make this a little bigger. Okay, now say for example you have that here is theta. Well, here theta is going to be somewhere between 0 and 90 degrees. So in that case, we would say that this is what we call an acute angle. Now, similarly, if I was to say, for example, draw a, let's see, if I was to draw something like this, and let's just use our imagination, and we'll just draw something like that. Well, here you have that theta is a right angle. So that's because theta is equal to 90 degrees in this case. So what we tend to call it is a right angle. which we're going to see a lot of those as we get more into the material, like as it relates to right triangles, because that's actually kind of interesting as it relates to, like if we had a triangle like so, then you can easily say that, for instance, that most students tend to memorize like a squared plus b squared equals to c squared. So we're going to see a lot of that throughout this course. Now, another angle measure that you will have is what we call an obtuse angle. So an obtuse angle is one of which that you have that the angle measure is somewhere between 90 degrees and 180. So we will call this an obtuse angle. Now, the other type of angles, and mind you that, we can talk about the geometry like acute triangles, right triangles, obtuse triangles, or isosceles and so on, and scaling, which is in the next section, but my point is that I don't like to get too caught up on really the geometry, um, even though like trigonometry is really geometry and algebra. So the last type of angle that we can look at is, say for example, that you form an angle that goes like so. Well, in this case, the angle is 180 degrees. Now, this is meant to be just like a line, for instance, but in this case, a straight line. So that's why we tend to call this one a straight angle. Now, in either case, like we might see some of these straight angles, for instance, because, for instance, let's say that, let me see if I can draw a circle. Okay. Now, in this case, like if you have that there's a straight angle, that means that basically that, the angle measure, it just went kind of like so, where you have that uh, it just formed like a kind of like a straight line or a 180 degrees. Now, when we start talking about the unit circle, this will probably just make more sense, but you could also just think of it like this. You know that 360 degrees is a full revolution, but this is only half the rotation. So in that case, 2 divided by that is 180. So you can see that this would have to be 180 because it's just half of the rotation. Okay, now one thing that we do talk about furthermore is looking at what we call complementary and supplementary. So for instance, we have that there are angle measures of which that, if we were to add them, that you would have that if this was, say, for example, like A and this was B, you have to have that A plus B equals to 90 degrees. Now, in this case, that would mean that that the angle is what we call complementary. Now, the other possibility is that if we have an angle measure, like say for example like this, and you have that this is going to be A and this is going to be B, well, you have that if A plus B equals to 180 degrees, this means that the angle measure is what we call supplementary. Okay, now in any case, we can actually use this to our knowledge, like when it comes to, some practical applications, of which we'll see later on in probably like the second chapter or so. But let's do some examples of for instance, complementary and supplementary angle measures. Now, let's say that we have an angle measure like so, and let's say that we have something like this. Now, what we're going to do here is we're just going to say, for example, that right. So we're just going to put that this is going to be 2x and this is going to be 3x. So let's say that, you just want to solve for the complementary angles. Okay, well, basically what we know is that 2x plus 3x equals to 90 degrees. But basically from here we have that this is going to give us that algebraically that we can combine this into 5x equals to 90. Now, this is actually just a linear equation, so that means that we can actually just divide by 5 on both sides. Now, if I do that, then basically that just kind of reduces it. So let's see, we have cancellation, so that gives us that x is equal to, well, let's see, 90 divided by 5, that's going to be 18. So we have that that's going to be 18. However, note that basically you had 2 times 18, so 2x. So we know that basically that 2x is equal to 36 degrees, and we know that 3x is equal to, well, 3 times 18 is going to be 54 degrees. So we have our solutions. Okay, now let's say that we wanted to do another question where, for example, that you had a, okay, let's do this. Okay, so we'll do this. We'll go ahead and draw a straight line as possible, and we'll have something like this. Now, let's say that this is going to be 7x, and that this is going to be 2x. Now, in this case, if we want to find the supplementary angle, then what we're going to do is we're just going to basically kind of like solve it algebraically, because we know that, for instance, that 2x plus 7x equals to 180. Well, algebraically, this means that 9x is equal to 180. But if we divide by 9 on both sides, that gives you that x is equal to 20. So we have that that's going to be 20. But note that basically this tells us that that the two angle measures that we have, let me see. Oh, you know what? These are kind of backwards, actually. Let's go ahead and just change this. Yeah, because yeah, let me just be more accurate. Uh, 7x and 2x. Okay, so that makes more sense now. Because I started to look at it and I was like, wait, that doesn't look entirely fine. So 20 times 7 is 140 degrees. And then we have that the other angle measure is going to be 2 times 20, which is going to be 40 degrees. So what that means is that the angle measures are as follows. And note that, you have one obtuse and one acute angle, but you don't really have to think of it that way. It's entirely up to you. Now, the other things of which that we can talk about within here is just a little bit about working with degrees, minutes, and seconds. So in this course, we do some applications that we will we'll have our measurements in degrees, minutes, and seconds. You can think of this as kind of like similar to what is that? GPS. So it's very similar to GPS coordinates. So we'll just put this as degrees, minutes, and seconds. Now, one thing of which that you can kind of relate a degree is that a single degree is actually equal to 1 hour. But if this is true, that means that basically that 1 degree is equal to 60 minutes. Now, the way that we write minutes is with this apostrophe looking symbol or prime symbol. Now, what that tells you essentially is that 1/60th of a degree is equal to 1 minute. Okay, so that's kind of interesting. Now, furthermore, if we were to kind of think of seconds, so seconds. So if we have that, 1 minute is equal to, let's say, like 60 seconds. So that's going to be 60 like that. Well, in this case, this is telling you that the relationship is that you have that this is going to be 1/60 for 1 second. But that means that basically that 1 second is equal to 1/3600 of a degree. So in that case, we have our kind of like our conversions almost for writing out, degrees from degrees to degrees, minutes, and seconds. Because, for instance, I can take an angle measure, like, let's say like 65.38 degrees, and I can convert that to degrees, minutes, and seconds. The way of which that I would do that is I would have to basically just take the 0.38 and I would have to multiply that by 60 to see like what does that give me for my minutes. And I can do that easily like right here. So like 0.38 times 60, so it gives me 22. So I have 22.8 minutes. But with this little extra portion, I would have to then multiply the 0.8 and multiply it by 60 as well. So in that case, this is going to give me what that is in seconds. So like, I will take 0.8 and I'll multiply that by 60 also. So I get that that's going to be 48 seconds. So what that means is that 65.38 degrees changes into 65 degrees, and then I have 22 minutes, and then I have 48 seconds. So in that case, the degrees minutes would look like this. And 65.38 degrees is completely arbitrary. And you don't really have to get too caught up on the dimensional analysis, but if you do think about the dimensional analysis, then it actually does work out. So again, like for example, if you had that you saw something like 12 degrees, 42 minutes, 38 seconds, basically that's going to be, 12 minutes, no, 12, 12 degrees, 42 minutes, and 38 seconds. Now, you can actually convert this as needed, back into degrees, basically. Okay, so let's go ahead and look at, for example, like adding degrees and I'm just going to put adding, subtracting. Um, okay, so what we can do here is, for example, look at the following. So I have 28 degrees and 35 minutes plus 63 degrees and 52 minutes. Now, when you add this, it's best to go ahead and just group these together. So we know that we can group the 28 and the 63 together, and then we know that we can group the 35 and the 52 together. Now, keep in mind that the adding only will work for common terms. So this equals to 91 degrees plus, well, you get 87, so you get 87 minutes. But one thing that you can kind of look at this as it relates to degrees, minutes, and seconds, notice that it's over 60. So that means that you can actually just borrow or carry, if you want to look at it like that. So you have 91 degrees, and we're going to break this down into 60 minutes plus 27 minutes. Now, this is actually just 1 degree, so that means that you have 91 plus 1 degree plus 27 minutes, and that equals to 92 degrees and 27 minutes. So what if we wanted to go ahead and just subtract then? Well, it would be more or less the exact same thing, where you would have that, okay, so what if you wanted to take 180 and subtract the following angle measure, 117 degrees and 29 minutes? Well, in this case, like what we can do here, so what we can do here is we can actually just borrow some of the degrees from 180. So what we'll do here is we'll just say that we have 179 degrees minus 117 degrees. And then now keep in mind that that's actually going to be plus 1 degree minus 29 minutes. Now keep in mind that, okay, you have 179 minus 117 degrees, and then you have plus 60 minutes minus 29. Now what this does is it gives us the following. It gives us 62, so that's going to be 62 degrees plus 31 minutes, but that's going to give you 62 degrees and 31 minutes, and that's it. Okay, and then let's go ahead and just look at this one. Okay, now one thing that we can do is go from degrees, or degree minutes second. So let's say that we want to go from degrees minutes seconds to degrees. Okay, well, for this, we're going to do the following. Let's say that we have 105 degrees, and then we have 20 minutes and 32 seconds. Now, the easiest way to do this is to basically just kind of do the conversions. So you have 105 degrees plus, well, you're going to take, okay, so the goal is to convert this. So you're going to take 20 and you're going to divide by 60, and that's going to be for the degrees. So that's going to be degree plus 32 divided by, well, remember that the conversion was that you have to multiply by 1 over 3600, so that's going to be 3600. and this is going to be of a degree. Now let's go ahead and just move on to the calculator because now we can actually just do that really easily. So we have 20 divided by 60, and that's going to be plus 32 divided by 3600, and then we just hit enter. Okay, so what that's doing is that's giving me 105.352. Now, in this case, like it's gonna be told to you like when to round or how to round. So like let's just assume that it was 3 decimal places. So we have that this is going to be approximately 105.342. And that was in degrees, okay? Now, another thing that we can do is look at, for example, what if you had an angle measure like 85 degrees or 85.263 degrees, and you wanted to convert this to degrees, minutes, and seconds? Now, what you're going to have to do basically is say that you have the 85 degrees plus, okay, so you're going to take the 0.263 and you're going to multiply by the 60 minutes. So in that case, you'll start to notice that it's going to give you some change. So 0.263 multiplied by 60. Now it gives you 15.78 minutes. So I'm just going to put 85 degrees plus 15 minutes and then plus 0.78 multiplied by 60 seconds. So what this is going to do is it's going to give us, should be like about 47. So let's see. Okay, so 0.78 multiplied by 60. And yeah, so we're going to round to the nearest minute on that one. So that's going to be 85 degrees plus 15 minutes and then plus 17 seconds. Or, of course, you can do the traditional DMS. So, like for example, like you have 85 degrees, 15 minutes, and 17 seconds. Okay, now, interestingly enough, I could have just put this in the calculator. Let me see. If I change my mode to my calculator, I believe I should be able to just do 85.263, and then from here go to uh, second apps, and then just select the fourth option. So see how like it gives me 85 degrees, 15 minutes, and then 47 seconds. Yeah, that should be a 4. Okay. So um, what we can look at furthermore is looking at the quadrant plane. So one thing though, before I move on to the quadrant plane is usually you will only use degrees, minutes, and seconds for like mostly applications, and with that, that's going to be like the bearing problems or like maybe like some of like the physics problems where we're modeling using vectors and things like that. So for the most part, we're going to be working in degrees or radians. But this is a fun little exercise. Doing like the conversions and whatnot. So let's think about, you know, the standard plane. So this is in regards to what we call standard position. So standard position is more like looking at the x and y plane. So for instance, like if I have a quadrant plane and let's say that we have our vertex is right here. Normally we tend to call this O. So let's say that this is our initial side as we mentioned. So we have that that's the initial. Now let's say that we form a vertex of which goes something like this. Well, in this case, like we have that the terminal side would be over here, like on this side. Now, I have that I can form my angle, so my angle is right there, theta, and we can go ahead and indicate some direction, so like something like that. Okay, now the thing that you would basically kind of identify in regards to like standard position is kind of like, where the terminal side lands, for that matter. So, for instance, you have that this right here is what we call quadrant 1. This one right here is what we call quadrant 2. This is quadrant 3. And then this is quadrant 4. Okay, now in any case, we have that, you can kind of think about it like this. Well, since I have that there are 4 quadrants, that means that you can actually think of it like this. If you were to basically kind of just rotate around 360 degrees, then in that case, that's going to tell you that based on the 4 quadrants, that each quadrant is worth 90 degrees. So you take 360 divided by 4, and that gives you 90 degrees. So what that means basically is that you can kind of just redraw your quadrants and just label them appropriately. So with that, you have that this would be 0, and then this would be 90, and then this would be 180, and then this would be 270 degrees. But if you come back around, like let's say for example that you went around one whole time, then in that case that implies that you went 360 degrees. So for that matter, you can actually put 360 right there. Now, here is where, yeah, you would label this appropriately as quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. Now you can see that if the angle falls in the quadrant 1, it's between 0 and 90. If it falls in quadrant 2, that it's between 90 and 180, and so on. So like 180, 270, 270, 360. Now, another kind of neat trick is that when we start talking about trigonometric functions, basically you have that you're going to be looking at the signs. So, for instance, if you kind of relate this to college algebra or just even algebra, you have that one side is positive, the other is negative. So, in that case, you're going to learn like this little acronym: all students take calculus. Now, this is with relation to the trigonometric functions. So, and those are sine, cosine, tangent, cosecant, secant, and cotangent. So, even though that may not make sense right now, you'll kind of see it as it comes along in the later chapters. So, for now, what we can actually just think about is, looking at an angle measure and its coterminal. So, for instance, when we use the term coterminal, we basically just want to say, what is an equivalent angle. So, for instance, when we talk about coterminal, we basically are just talking about taking an angle measure theta and setting it equal to 360 degrees multiplied by n plus some theta prime. this is the definition of what we call a coterminal angle. So basically you have that the coterminal is the theta prime, okay? So in this sense, the n is really just telling you how many rotations need to be applied. So think of it like this. What if you had 480 degrees? Well, one way that you can think of this is that, well, I know that I can actually rewrite this as 360 degrees times 1 plus 120. So what the 1 is telling you is that you went around one whole time. So let's look at it like, what does that kind of look like? So you have that 480 means that you went around one whole time, but then you added another 120 degrees. So let's just have it like that. So in this case, this is the 360 plus the 120. So in that case, this angle measure, theta prime, is equal to 120. But where does it terminate? It terminates in quadrant 2. So in that case, you have that it's an obtuse angle with respect to the standard position or the initial position. Now, you can do that again another time. Like for example, let's say that you have um, minus 45 degrees. Well, here, minus 45 degrees, it's a little bit tricky because you have that it's not really telling you like what happened, but think of it like this. If we go ahead and we consider the x and y plane or the coordinate axes, so we know that minus 45 degrees, if we go in the opposite direction, y, because it's negative, that it's going to look something like this, that where you formed the negative angle. But if we think of it from the other side of it, we have that, well, in order to meet back over here, we had to go something like this. So that's almost like saying that you could have just taken 360 minus 45, and then that's going to tell you what the coterminal angle is. But let's think of it like this. Because you have that theta is less than 0, that means that you just have to add 360 appropriately. So you take minus 45 degrees, and you, not equals, but you would add 360 degrees, and this is going to equal to 315 degrees. So basically we find that the coterminal angle is 360 degrees, and you have that the the yeah that the angle negative 45 can be rewritten in the following manner, where you have that that's minus 45 degrees. Uh, it doesn't matter actually technically. Like you can say like minus 45 equals to 360, but that's negative 1, and then plus 315 degrees. So what this is going to make you do is just try to remember like what n is, and it's going to tell you that n is an integer. So it just means that, uh, n can be like so n is sort of like negative 2, negative 1, 0, 1, 2, and so on. So that's going to allow you to kind of like think of it that way. Now, another way that you could have thought of like 480, for instance, notice that 480 is greater than 360. So 480 being greater than 360 means that basically you could have just subtracted 360 the appropriate number of times, so that's 120. Okay, so in that sense, it tells me that I just need to subtract it one whole time to get the angle measure. Um, Now, let's say, for example, that we wanted to find the coterminal angle for 1,106 degrees. Now, notice that this is actually greater than 360. So that means that we need to subtract this the appropriate number of times, the 360. So let's say that we do 106 minus 360. Well, for this, like, we know that that's going to be 746 or something like that. So let's see, 1106 minus 360. Yeah, so 746. Now, 746 is actually still too big, so we have that 746 still needs to be subtracted. So you have 746 minus 360 degrees. Now, in this case, we have that that's going to be where we need it, because essentially you need theta prime to be somewhere between 0 and 360. So it tells you that the coterminal angle is 386 degrees. So what that means is that you have that 1106 degrees is equal to um, let's see. So basically that tells us that we went around twice, and that's 386 degrees. Because yeah, basically you have that's 720 plus 386. So like if you wanted to see that in the x and y plane, you would just note that how many times did you go around? You went around twice. What did you add on to it? You added on that, after you went around one, you went around a second time, but then you kept going until you reached 386 degrees. Um, Actually, let me do this again, because yeah, that's not right. Um, right, so 360, 720, and then we have to go around one more time technically. Hang on, actually, uh, there's a mistake here. Yeah, it's good to kind of make these little mistakes, because then, like, you'll know that you'll have to do something else. So, okay, now I can see that we're going to take 386 minus 360 degrees, and that's going to give you 26 degrees. So, wow, that meant that I had to subtract three whole times. So, in actuality, we have that the angle measure is very small. It's going to be just 26 degrees. So, we have 1, 2, and then we have the third, and it's an acute angle, so we'll just do something like that. So we have that this terminated in quadrant 1, okay, and 26 degrees is definitely an acute angle, but it's also the coterminal angle. Now, one way that we could have done this, another way, is that we could have probably just figured out, like, how many times do we need to subtract 360? And for me, my mistake was that I didn't realize that 386 was greater than 360. So divided by 360, it tells me that I need to round down. So we just need to subtract it three times and then go ahead and just see what that is. So that's going to give us the 26 coterminal angle and like where it terminated. So it terminated in quadrant 1, right? Now, negative 150, let's say that you had negative 150 and you wanted to find the coterminal angle. Well, you have that it's less than 0, which means that you need to add 360 the appropriate number of times. So you have negative 150 plus 360 degrees. Now, in that case, that's just going to be 210. So that equals to 210 degrees. Now, that's actually not too bad because you can actually just draw that in the x and y plane. But this is what it's going to look like. It's going to look something like this. Okay, now this is definitely not to scale, but one way that you can look at it is that there's a rotation that creates a negative 150 degrees, but notice that they share the same terminal same terminal. So basically you have that for this one, it went like that, but what is that angle measure? Well, that angle measure is 210 degrees. Where did it terminate? Well, they both terminate in quadrant 3. So in that case, we have that the coterminal angle is 210 degrees. Now, it's kind of not too bad that you can kind of see that, well, you just need to add 360 one time. So that means that if you do that shortcut, that you just need to round up as opposed to down, probably. So like, for example, if we look at negative 603, then you just need to take that divided by 360. So you probably need to round to 2. So that means that you'll take 360 multiplied by 2 plus negative 603, and that gives you 117. So 117 is the coterminal angle. If you happen to write something like, that it's equal to 117, technically this is not right, but, I think I kind of understand where you're coming from. But to be more precise, like if you were going to rewrite this, you would have to put 360 degrees multiplied by 2 plus 117 degrees. And then that would be it. Now, I would say, for example, try to find coterminal angles for, like, say, for example, like 0, 90, 180, 270. And then maybe try some like 45, well, 30, 45, 60, and that would probably be it for now. I think that's a good end. Um, so just as kind of like a recap, in terms of like coterminal angles, you basically know that essentially that it's gonna stop somewhere, the rotation. So you have that, if for example that you had that your angle measure was equal to, let me see, well, let's just say like 135. Well, in this case, there's nothing to do here. Why? Because it's between 0 and 360. So in this case, this is one of those situations where the coterminal angle is equal to the angle. So in that case, like you have that the termination is going to be in the second quadrant. Why? Because you have that the angle measure looks something like this in regards to what is 135. You have that it just looks like that. So you have that this is going to be 135 degrees, but where does it terminate? It terminates in quadrant 2. Now, furthermore, you could probably find more angles that would be coterminal to this one. How would you do that? You would just add 360 or subtract 360. So, like for example, 495 is coterminal to 135, and then you have that 855 is coterminal to 135 and so on. So try to look at some of those possibilities when it comes to finding coterminal angles. And again, that formula is theta equals to 360 degrees multiplied by n, and then plus theta prime, where theta prime is basically the coterminal angle. Okay?